Hey everybody, welcome back to another episode of the Data Sense podcast. We're doing something a little bit different today. I'm going to be introducing and interviewing Zane Danielle from ML Sense, and I'm Stephen Pope. And this is just going to be a special episode where we dig into what he does, where he came from, and some specific ways that he works through with clients and the outcomes that they're able to achieve, and really get into some of those details so we can see what happens behind the scenes. Zane, welcome to the show, man. Welcome to your show.
Thanks. Yeah. Thanks for hosting me.
Yeah, no problem. So sometimes the best place to start in these things is really just like the end. So I'd really like to just dig into like what specifically, I know from a broad perspective that you help clients, generate more revenue, save time, save money. But let's get into a little bit more specifics on how you help clients and what you're doing now with the clients that you have.
Sure. Yeah. So most recently, we have had in total saved clients more than 23.5 million pounds. That's across multiple clients. There was one client which we saved 2 million or slightly more than 2 million. And that was through a lot of data engineering, but first discovery of what the problem is, and then data engineering. And within the first month of when the solution was implemented, they were able to save 220,000 pounds per month, basically.
Gotcha. And I don't know if you're allowed to talk in specifics about that particular client, but if you are, like what was it that you were able to discover and then implement that allowed you to get such a huge result?
Yeah, sure. So one major thing, or they had quite a few things. They were going through a mini digital transformation. They had, in fact, all of their tools were on Excel. So it was like replacing an Excel tool with basically a web app with database. And the reason why it was special is that with Excel, sometimes it breaks. Sometimes someone who made the application on Excel, which you can, right? It's really funny. That is really old. And sometimes it's made with, the 2003 version. And sometimes it just breaks. But the usage of that basically impacts the business. So what was happening was that they were using Excel for the timesheets. And they had like 100 people who were putting their hours up, in the timesheet. Now 200 people, they needed to select the right job codes. They could not select the right job codes because sometimes they could not find them. Sometimes they were not appearing on time. So they had to basically just put overhead. Now, the thing is, when you put overhead, what it means is that it's whatever, right? And then the company pays. The company cannot put that time on an invoice and charge the client. So that was a major issue. Now, in order to solve that, we have to sort of allow take care of the users on how they put the timesheets in. So a web app, which has a really good UX, and then basically make sure that for each of those people who are in those projects, we only give them the limited options available. And not like if there are, say, 200 different projects, they will only see 10 different projects because they can only work on 10 different projects, right? So that basically gives them a better option to basically select the right timesheets, job codes. And that basically meant they were now doing timesheets properly. And that basically meant that their time could be put in the invoices, funnily, and charged back to the client. Now, what that means is that it actually directly impacts the sales or the total revenue. And such a problem, it just makes sense. Why would you not do it, basically?
Yeah. So in this particular engagement, was this a problem that they already were aware of?
They were aware of the problem that, oh yeah, we are losing some money. They knew where how they roughly knew how much money they were losing, but they did not know if there was a solution that could really basically get them, pretty much 100% of what they were losing back in the first month.
Hmm. Yeah.
And what they were thinking is that, oh, it's gonna be like a slow process, will take like years, probably 1 year at least, to go and start being able to claim back, or us getting a visibility on the hours. That was their sort of vision, that, oh, it'll take some time to get the visibility, but what they got was the visibility on day one. So that was something like, they thought we were magicians.
Yeah. That's cool. Yeah, it's amazing how like a spreadsheet, they can be really powerful. You can build interesting things on it, but like once the person that builds that spreadsheet leaves, or once, or after a while, that spreadsheet could become brittle. There was another company I worked with where back in the days, where they had a similar situation. But it's amazing to think about like how you can make a simple change and I mean, there's probably tons of companies still using those spreadsheets across all industries. I know like the mortgage industry is often using spreadsheets to do lots of complex calculations. CPAs are notorious for this kind of stuff. So it's just interesting that you were able to come in and just do a small tweak. And now, were you able to go back in the past and also reclaim some revenue that was unaccounted for, or did it basically start from when you implemented your solution?
Well, the thing is that it depends on the industry and depends on how they've set up their invoicing structure with the project. So they could not claim back the previous one, uh, because the client would have said, "Well, you already charged us back, and you submitted the timesheets. How, if
Right.
this is wrong, then we will lose trust in you and stuff." So it's really awkward. But they
Yep.
are, just to maintain the good relations, they are happy to say, you know what, at least now we have the right record. So that's what happens. It you can't do it, going backwards, unfortunately. Yeah.
Got it. Yeah, that makes sense. And it really is just quite interesting because like we talk about all of this advanced technology that's available to us, and when it's properly used, it can have a huge impact. But in this case, it was a pretty straightforward thing. It's like just identifying where this bottleneck was in the company and implementing a fairly simple solution that returned a ton of revenue.
Yeah, it was. I mean, Excel is pretty simple. Excel, as you mentioned, it's a great tool. And Google Sheets, it's a great tool, absolutely amazing. But the moment you start building apps out of that, or the moment you start building something extremely complex out of that, at some point it's gonna break and it's gonna cost a lot of money. So it's just, it's a bit like, it is a tech debt. You have to sort of think about it and make sure you pay that tech debt at some point. But if you pay it later, obviously that means you are going to lose some money.
Yeah, great. So, in a nutshell, you come into companies, identify problems that are costing them money, wasting time, or like limiting revenue, and then you engineer solutions that will maximize basically those three variables.
Yeah, sometimes it's directly impacting the sales. Sometimes it's not. Sometimes it's, say, creating cloud infrastructure for something totally new. Um,
And
so, for example,
so you
go on.
oh, go ahead.
Yeah. So, for example, cloud infrastructure for, like, in machine learning. So there was a client, a government department, that basically came and asked for, basically a machine learning infrastructure on AWS, and that is basically what they needed, was good security, automated creation and destroying of the infrastructure, and being able to basically create and destroy as many times as possible without any consequences. And the code is theirs, but the good security still needs to be maintained. So those were, I guess, two really specific requirements, and the third one obviously being you have to be cost effective. Although yes, it can be slightly expensive if the security, if you need to make it more expensive to maintain security, then yes, because security is number one. But after that, you have to sort of optimize the cost as well. So I guess there were three major requirements, and that's a totally brand new project. So cloud infrastructure for machine learning. Yeah, so that's what I would say. It's something totally new. It doesn't
Yeah.
impact the sales. It doesn't impact the revenue. It doesn't impact directly, at least. Obviously, it allows data scientists to go and solve problems and see if that goes and impacts the sales.
So that's probably something like, so you're obviously a very technical person, but sometimes, and I think this happens in most industries, but there's usually going to be like trying to identify a specific problem that's going to have a very specific output, and then there's also like just identifying, hey, if we start to think about this and implement this, this could provide us an opportunity in the future. So I'm assuming that you've learned how to think about this in business terms and talk about these things with business people. So how is it that you like, what is it, how is it that you talk to these business people? What have you learned that allows you to communicate to business people and either suggest immediate technology that's going to have an impact tomorrow, or like, hey, how can we strategically think ahead such that this is worth spending maybe a considerable amount of money without a specific result like 3 months from now?
Yeah, so sure. So I think you have basically transitioned into something exactly what I would basically talk about, where this was a government department, and with the government department, the cost is not the main issue. Normally, it's the functionality, security, and what it allows you to sort of do and the teams to do. The cost comes afterwards. And whereas even for large organizations, enterprise organizations, it's roughly the same, where the cost is not the main factor of deciding whether to go for a solution or not. It's mainly the security. It's mainly the what it allows you to do. And for large businesses, the cost obviously matters. So what matters is the way it matters is that number one, if you are able to help reduce the number of people working who are doing something manual, right? If there are people who are checking invoices manually, and you put an AI there that can scan, that can categorize and put the invoices in the right places, that basically is a good thing, right? And then if there's something else where someone is checking some documents manually, and you are able to automate that using some sort of document processing, that is something great. So if you're able to, number one is that helping large enterprises reduce the number of people who are doing manual or less creative work. Um, as we go into the future, it seems like uh, the best thing is, or what people really pay for, is the human thought. It's basically, if you have engineered something, because you consciously have thought of something and you have engineered something, you have created something that works really well. If you are doing something manual, that can be done by a robot or a AI script or something, uh, or some robotic automation, then it's likely that soon enough a human would not be doing that job.
Right.
So that's what I feel. So that's why we should not be too pessimistic about losing our jobs. I'm sure most of jobs are going towards that direction of creative jobs rather than something where you're doing mundane or repetitive manual work. Now the thing is that, so going back to my point about enterprise companies, enterprise level, number one thing is the reducing number of people who are involved doing something manual. Second is saving money. Third is making money. and saving money has to be significant enough. It can't be that if there's a project, right, that costs £100,000 or dollars, and the saving is about £110,000. That's like it's okay. The saving is not large enough for us to be
Right.
involved, because we have to sort of think about it and be involved in the process. And there's a lot of other costs that are hidden, the HR cost,
Right.
the signing contracts and the paperwork and all that stuff.
Right.
It
Right.
has to save a lot more money. It has to save a lot more money for it to be viable solution. Uh,
I call those like like they have to be a no-brainer.
yeah, it has to be. And the other thing is that, that's one thing with large enterprises. With small companies, the thing is that if they don't have enough data, then it's very difficult for them to use AI, because AI is a data driven process, and you need a lot of data to be able to play with it, to be able to see what you can do. And before you do AI, you need to do a lot of data engineering. There are a lot of low hanging fruits, such as just tidying up the data, putting the data in the right place, connecting the dots. There's a lot of basically a lot of data, that a lot of processes that can go before you even think about AI. So for small companies, so the best way I put it is that, suppose we come in and we do a job, and we are there to we quote for something like £10,000 per month, and for this particular job, that's just the lowest cost. Now, if we are there to optimize, say, Google Ads budget, right? The issue is that if we are working with a small company that only spends about £30,000 per month on Google Ads, and we are saying we will manage your ads or optimize your budgets, but it's going to cost 10,000, then it does not make sense for them to basically
Right.
engage with us, because
Sure.
they're not spending enough money. They're not big enough. They don't have the problems that we can solve, basically.
Right.
So
Gotcha.
only a large organization which is spending something, around £100,000 per month at least, to then say, you know what, we need to really optimize this. Let's build our own bespoke AI engine, and let us look into that. Basically, that's where we can get involved. So it's basically
Yeah.
big data. Sorry, data is a big company's game, large company's game. Small companies can't get involved if they don't have a lot of data, and if that data or if that function is not producing enough money, then it's difficult to get involved.
So maybe like when you do engage a small company, maybe some of the things that you're going to talk with them about is like, hey, how can we start getting you in a position where you're collecting this data so that as you grow, you have a reservoir of data that when it makes sense, you're going to have this available to do some of the more complex work.
Yeah, exactly that. In fact, I had a call with a client, with a potential client recently, and that was exactly that, where I basically mentioned that they need to start gathering the data, and I advised that you need to go and gather the data. You can use Google Sheets, Google Forms, and even that is great. That's free, and that will do a great job. And the great thing is
Interesting.
that once you have the data, then you can play with it. Then you can see what you need to do. So for a startup, I would say that, yeah, first of all, find ways that you can gather data, you know, as cheaply as possible, so you can start to play with it in the sense that see how what are the sort of opportunities in the data, what are you trying to sell, how are you trying to sell that, and if the data sort of validates or helps you solve that problem.
Yeah.
Yeah, and then once you sort of scale and you have a lot of data, then you suddenly have the problems that we can solve.
Right. Gotcha. Cool. So this is great. You've built this awesome company. You're helping other awesome companies implement this technology. Real quick, talk to me a little bit about how you got here. Like, what's the story? Like, what were like the 3 or 4 steps that you've gone through in your career that have kind of led you here to this spot right now? Like, what were some of those moments that you ran into that led you here?
I was a software engineer. So I was like a
Yeah.
software engineer who just loves technology. And the thing is that what got me into this, I would say that I was able to see what impact I could have as a software engineer in organizations
Mm.
by seeing
Mm.
the business case for certain problems. If I solve a problem, what impact it has across the whole organization. And I was able to see that very quickly. And I then realized that,
Cool.
you know what, this is really interesting. I could really take this far. So that was the initial sort of thought process. Oh, you know what? For example, with one company, before I started ML Sense, I was a contractor. And as a contractor, so one thing I did was I was able to save 25,000 pounds for one company as a contractor. And I realized that I, this problem that I just solved here exists in many other organizations. They just need
Mm.
to have the solution. I don't need to go and work for each organization and or do a contract with each organization and then go there, sit there for 3 months or 6 months, and then solve the solution or solve the problem and provide the solution. I could just do that. Like I could just offer them the solution. So
Yeah.
it's that sort of realization that this problem that I've seen here, I've seen it in 4 different places for other companies,
Mm.
and that makes you realize that there's a lot of problems that can be solved, and there's a lot of low hanging fruits.
Mm. Yeah. Yeah. I think that's key, especially with technology implementation, is seeing the business value of it,
Yeah,
seeing the low hanging fruit, right?
yeah,
Because like there are so many engineers out there, and I've been guilty of this in the past as well, where it's just kind of fun to implement something,
yeah.
but it doesn't necessarily lead to a good outcome, right? It's like it maybe it even adds work or it doesn't work. So like being able to see like an outcome or the impact you can do on a business level, I think it sounds like that's the key epiphany you had, that you had that ability.
Yeah, so I actually advise against trying new technology for fun, um,
Yeah.
because new technologies are so it's opposite cars. It's not like a new car. It's
Right.
new technologies break, uh, and they are often really buggy because the person who designed it never really thought of all the scenarios or most of the scenarios where it could be applied. And so it is buggy and it breaks and it could affect your production code. Now, the thing is that when that happens, it's a huge issue. So I've seen a lot of uh, basically, I guess, companies play with new technology because it's new. It's literally because it's new, and I basically advise against that, especially to a small company. For enterprise, you know what? They can play with it. They can break things, and that's fine. They're too big to sort of fail too quickly, at least.
Yeah. No, and to your point, like engineers in general, like a lot of the time when you ask them what technology should you use, it's always the one they use, right?
Yeah.
It has nothing to do with like whether it's the right one for you. It's just like, oh, I use this one, I love it, so then you should use it. Uh, maybe there's one exception, and like for me, myself, like when I saw Docker come out, like a light bulb went off in my head because I saw like that was something that like enabled something new. I mean, I know that containers had existed before, but when Docker came out, that was something new that enabled companies to do something that was relatively hard to do before. So I felt like that was an exception to the rule where I was like, oh, this is like a new opportunity. So I felt like trying to use that technology. But I think that's kind of like more rare. Like if just a new technology comes out or a new language, it's like, how is it really going to do something different than what's been done before?
Yeah. So for on that, what I would say is that even Docker in its really early days was buggy.
Right.
So
Yeah, that's true.
I would say that let others play with it. You know, don't
Yeah.
become the guinea pig yourself.
Right.
Especially for a
Yeah.
small organization, especially for like a startup or like a really small department in a company which is not a software or internet company, because it can sort of impact other things. Whereas if once Docker came out, it took a few years, and it just became the standard. Now, when it becomes a standard, there's a lot of documentation. There's a lot of
Support. Yeah.
support. A lot of people have done the same thing that you're trying to do with Docker. It just works. It's just great.
Right.
So then it just makes sense. And the other thing about Docker is that Docker has this Docker Hub, which is like the repository where there are other images. Now the thing is, when it came out, the images were not there, but now there are. So when it first came out in the first year, it would have had very little support for a lot of the technologies, but now it just seems to have everything. Now it just seems to have even total apps in on Docker Hub,
Right.
where
Right.
you
Right.
just take one image and you download it, and then you pass a command, and you're good to go. You're basically good to go. You don't even have to do anything else. So
Yeah.
now it's really advanced. Yeah. So
Yeah.
yeah, I agree. It makes sense. It's just that sometimes Microsoft comes out with like a latest technology, which is like .NET, .NET 5, and .NET 5 comes out, and it's like a breaking change from .NET 3.1, and it's .NET 3.1 is breaking change from 3, and 3 is breaking change from 2.2. So it's like,
Yeah.
what is going on here?
Yeah.
And
For
that's
sure.
something I would advise I would not use in production.
Yeah, that's a good point. And
Yeah.
I even remember like when Docker came out, like there were a bunch of like services that came out. I can't remember the name of them, but if you adopted it, like I remember some of them, like I remember Docker even bought some of those services up and then discontinued them, and so you had to move. So great point. So let's jump into like the process you use with your clients. So I know there's basically three steps, and you do discovery. You're doing data strategy. That's step one, and then you're doing data engineering and implementation, and then you're also after that, depending on the project, you're doing actual AI implementation, and then cloud infrastructure. So when you start with the discovery, what does that process look like?
So it basically, first of all, it looks like what the client wants. What is their want? Sometimes it's a problem. Sometimes it's just, oh, we want to be cool. We just got 30 million. We just made 30 million revenue extra. You know, we want to try something new.
Interesting.
Uh, and we think AI is that new thing. So
Hmm.
sometimes it's a real problem that we can solve. Sometimes it's basically they're trying to understand their processes, what should be done,
Hmm.
and sometimes they just want to play with latest technology. So the fact that they are actually asking for my advice is a good thing, because it means that they're being somewhat careful, right? They could have just said, "We have the money, we're gonna go and do it. We're not gonna ask anyone." The fact that they're asking someone just to verify, I think it's a good thing, because it just means that, you know what, I can advise them on. You have money, that's great, but there are low-hanging fruits. If you get those, you'll get more money. Yeah.
Hmm. Yeah. Cool. So then, you're working through the client. You're listening to what they want, whether that's like a specific project pain point or just to learn how to move into a space. Like as you come out of discovery, like what does life look like for them now? Like they understand the scope of what they might be getting into, or like tell me a little bit about like what life looks like after discovery.
Sure. So initially there's a discovery, right? So what happens is they discover, we both discover what the problem is, and they could have some thought process of what they need to do to solve it. So they would tell me, oh yeah, this is something that we think we can do, and this is going to solve the problem. Can you actually do and implement it? So they might feel that. Um, and My job is to discover what the problem is, and to discover what the real um, issue is, or if they have a lot of money, what are their problems still. Obviously they still have some problems, right? And if they're not able to articulate, sometimes they just cannot. Sometimes it's difficult to, they'll say we don't have problems. And you can imagine, right? They're like, yeah, we they probably have problems, but they're like, we don't know what the problems are. We're
Yeah.
doing good. Look, we just made a lot of money. So in that case, what you do is you have to ask, what are your goals, business goals, and you have to then look at what they look like in 5 years' time, and you have to try and align a solution. Say if it's a large company and a large department which has a lot of money, and you clearly can't see any problems, and the problems that you can see are directly connected with other departments which you do not have the power to solve, then you have to basically, you know what, say fine, that's fine. Let's work on something new. For example, AI. So when that happens, then you have to align with business goals. What are their goals? Where they want to go in the next 5 years, and then look at how we can get there. We basically go and we look at the data in terms of, if it's a they want to expand into new markets, we look at what the new market, what they are, can they define them, can we get their data, can we start to look at their data, can we start to analyze what that looks like. So the next sort of stage is, if they don't have problems, or they're having difficulty to articulate, we look at their business goals, and we then start to find some data sources to put together a solution. It would also mean we have to put together a data infrastructure, or some sort of a data platform for them to do data analysis and machine learning on. We would do that. Just we will do that only after making sure they're happy with the costs that are involved, not our costs, but the costs of actually maintaining, the training the data, and running the actual infrastructure. So if they're happy with that, then we would say, you know what, that's yeah, you could do that. That's not a problem. Whereas if it's a small organization, say they have a problem, they would say, okay, this is the problem. This is like, for example, another similar problem I can give to the one I talked about earlier. Um, it's basically to do with invoices for an energy company now. Now, with this company, they had data all across different places, and different companies had their data because they're using different services like APIs for meter reading, and certain APIs for the customers' data and stuff like that. So their data that they owned, because it's their customers, was sitting in different places. Now, only when they have the data in one place, and have it in a particular data format, or a schema, I would say, like, name, address, customers name, um, address, and bank details, and which stage the customer is at in terms of, have they signed up, have they paid, have they given meter readings, or have we connected to their meter through the API, something like that. And only when you have all the data in the right place, in the right format, then they can raise an invoice, and get the money paid for that customer. Now the thing is that if they don't have that data in one place, they cannot get the invoice paid, and that basically directly impacts the sales. So for that problem, it's a simple thing. We have to go and implement a data engineering solution. We have to go and implement something that brings the data together from various places into a single place. And what's once it's in a single place, we have to put it into a right format, and then make sure that this is happening daily and at a lower cost, and then give it to the client. So then the client can go and uh, raise invoices, do what they need to do, sales basically. So
Gotcha.
that's basically the what it looks like in terms of data engineering. Sometimes it's connecting APIs. Sometimes it's spinning up instances of Cloud Function, Cloud Run on Google Cloud Platform, GCP. And the thing is with GCP, we have to try and create things which are as cheap as possible, as cost effective, not cheap, I would say, as cost effective as possible, that do the job fully effectively, but are not like expensive. They don't need to be expensive. I don't think
Right.
that if it's expensive, it's cool. I don't believe that. I think it has to be, technology has to deliver results.
Right.
Yeah.
Sure. Yeah, that makes sense. So then, we've talked about discovery and then the data engineering piece of it. When is it that you really start to implement like AI solutions? Like what's happening in a company where you're actually starting to say, okay, it's not just the data engineering thing where we're building an app or we're doing APIs. Now let's like implement some actual AI that's going to help you do or gain you some insight.
That's a great question. Uh, I'm actually glad you asked it because I love to answer that one. So the thing is that with such a thing, I would talk about a case study where we helped a company with flood prevention using AI,
Hmm.
and that's where AI just makes sense. It's like, yes, we have to use AI now, right? So
Hmm.
the thing is that they were already gathering data. They were already gathering data in the right format, putting it in a single data warehouse, keeping it updated. Data was consistent. So they were doing a good few things well, right? And it's not a company which is good in that sort of culture. So they were gathering data, keeping it updated in a single place, in a single schema. And the fifth thing I would say, it's consistent across the whole country. So it's the data is actually of pipes on UK highways. By highways, what I mean is roads and motorways and big roads and small roads and everything. Um, so they were gathering that data of pipes, how clean the pipes are, how much water flows through them, how high they are, how high is one pipe, what's the angle of one from one sort of gutter to the next one, so the two sections, like, and then how clean is one gutter, how clean is the other one, all that sort of data. They were gathering it,
Interesting.
and they were keeping it, and they're doing a really great job.
Cool.
Like it's unbelievable, but somehow they were. And the thing is that they were also gathering another data source, or I would say a data set. So another data set was the floods index. So the floods index recorded across the country in the basically floods, when it happened, the date, where it happened, the location, and what happened, as in what the level was of the flood. And with that, um, so yeah, and with that, what happens is you can connect that data set, which is the pipes data and the flood index and the weather data, to build an equation. So they had a problem with floods, right? They are gathering floods data, they're recording it, but they don't know what they can use that for. But they're just gathering it, which is great. And it took ML Sense to come and connect the dots and say, well, there's a really good relationship here. You have pipes data, you have flood index, and you have weather. What that means is when it rains, weather data, when it rains, if the pipe is not clean, the water it's gonna be high. It's gonna flood. And so that if the we will know from pipe, we will know from the weather data that it rained. We will know from the pipes data if it's dirty or not from that location. And then the third one is the flooding, if the flood happened. So we use that data to build up that relationship. And once we build up that relationship, we will basically we have a relationship based on previous data, based on historical data. Then we will use that data to basically go ahead and predict for future. It's only sort of viable for up to 1 week of prediction. So you can predict that if it's going to rain, and we will basically plug in the numbers, and it will give us on a map where it's likely to rain based on that.
And
So
then likely
that's
to flood based off of the conditions of everything.
Yeah, and the pipes data was really good because they kept on updating. So then what happens is the ideal scenario is that when there is a storm warning, right? The Met Office is going to give us a snow warning. Oh, sorry, no, like a storm warning.
Right.
What happens is that we know in a particular location the storm is going to hit this location. We go and we mark that location and we check how much rain we are going to expect on those days. And we basically plug in the numbers in the model, and it gives us the hot spots of where the flooding is likely to occur, which is based on the pipes data and the flood index data. And that basically means that, say, if you have like 4 hotspots or 3 hotspots, that's great because then that company can go and send those basically people to go and clean the pipes off those locations.
Got it. Yeah.
And
Perfect.
and that's just a great insight. You cannot have that. You could not have that before. Because it's gonna be raining a lot. The storm is coming. It could just flood anywhere, right? You're just guessing. I don't know where it's gonna flood, but now you have data to know it's going to flood there, and this is likely to flood more. Let's go and first clean those pipes, and that's
Yeah,
the
that's
low
amazing.
hanging fruit. We can just once the pipes are clean, we know the risk is lower.
Yeah.
Yeah.
I bet you wish all your clients had all that data just sitting there waiting for you to
Yeah,
come in there.
yeah. Of course,
Well, it's a
I love that. Yeah,
well, it's a good reminder for companies to really start thinking about like how are you going to keep this data? Like how are you going to store it for a future time when you'll really be able to use it properly?
yeah. So it's a difficult one. I would say, yeah. So that's something. That's something. Yeah, you have to sort of trust the future or something.
Right. Yeah.
You
You have to
have
have
to.
faith in where the world's going.
Yeah, you have to keep. You have to. I would say whatever data you have, just keep it. You're gonna use it at some point.
Yeah.
Yeah.
And even if it's not perfect, you can come in and massage it and put it in the right format.
Yeah. Yeah.
Yeah.
Sometimes you can
Interesting.
fill up the gaps depending on the
Hmm.
data. Sometimes you can really do that, but and that's why I would say that it's better to keep the data, save the data. It will be used later, and it could be a game changer. You don't even know.
Yeah. Well, that's really interesting, man. So if somebody was watching this and was interested in like what you might be able to do for them, what's the best way that they should get a hold of you?
Um, connect me on, connect me LinkedIn, I guess. Connect me on LinkedIn or Twitter or visit the website. Yeah,
Yeah.
yeah.
And the website is
mlsense.ai.
nice. Well, cool, man. Well, thanks for taking the time to dig into what you do, how you got there, and then specifically these 3 steps: the data strategy, the data implementation, or the data engineering, and then also like practical uses of AI implementation. So thanks for walking us through that. I appreciate it.
No problem.
All right. Well, you'll be the host next time, but thanks everybody for being here, and we'll see you on the next episode, and we'll talk to you soon.
Cheers. Thank you.